All right, class, time for part two of this week's lecture. I made the mistake of eating dinner in between part one and part two. I'm now suffering from a food coma, so forgive me if my speech is impaired. It's because I'm busy digesting, but I'm going to make it. I'm going to do it. We're going to make it through part two. All right. Now we're going to talk about industrial uses. This is something that is very challenging for water conservation folks. I think I've already mentioned that, there's just so much variation from industry to industry that it can be very, very difficult for us to know how to advise one particular company how to change their water use to get more conservation and savings. But there are some big sort of notorious industries that use a lot of water. Paper, pulp mills, paper mills. Don't see that a lot in Southern California. For one, that is something that's typically near a forest, right? Forestry. Tends to be in the Pacific Northwest, also somewhat in the Northeast. Canada has a um, big industry in this, British Columbia in particular, but very water intensive. For us, not such an issue. However, we do have petroleum and coal, right? Petroleum is a huge business here in Long Beach, and actually our number one purchaser of recycled water in the city of Long Beach are the Thumbs oil islands, right? Which is there's oil. If you haven't seen them, they're islands sitting out in Long Beach Harbor here, and they are doing some sort of offshore drilling, basically, and they use recycled water to replenish what they have taken out of the ground, so that they don't subside, essentially. They do that there. They do that in Signal Hill, areas around here where they're drilling. They use water for various purposes in the oil processing, but also sort of in the drilling process. Chemical industries, food industries, metal plating, various metal industries takes up quite a bit of water as well. All right, let's talk about the public side now. Volume for fires, typically small. However, they need a lot of water at once. So, what we're saying is fires don't happen very often. Typically, particularly in an urban area, in the grand scheme of things, the water that they use to fight a fire is generally small. Like I said, it doesn't happen very often, so when you think about it on an annual basis, it's really a small amount of water. But they need it all at once, right? Very high flow rate. Those of you who work on the operations side of things probably know that we're required to uh, supply our customers with a minimum of 20 psi for fire flow conditions, right? You can see that down here in our last bullet point. We cannot supply below 20 psi. Okay, so it is something to consider. But in terms of water conservation, obviously, if you need the water to fight a fire, you're going to use it. It's not something that we really think about from a conservation perspective, although there have been some circumstances where fire departments have been able to use recycled water for training purposes, right? They have to simulate firefighting sometimes. So it's a great thing to be able to use non-potable water to simulate that. Other public non-residential uses, right? Public parks, golf courses, recreational areas. Those are great places to use recycled water. Those are also great places to cut down on turf where you can. Obviously, not the golf course, not the best spot for cutting down turf. But, more and more public parks are starting to incorporate water conserving landscapes, California friendly landscapes into their designs, right? You're seeing a lot more of like decomposed granite paths and pavers, meandering through a garden as opposed to just a large swath of grass. Not to say that there isn't a purpose for grass, right? If you want to throw a frisbee around or, throw a ball for your dog, play soccer, whatever, it's very useful to have a big piece of grass. But maybe only half the park needs to be grass, and the other half could be, a more apt landscape for this climate. So something to think about. We are seeing that more and more. But office buildings, firefighting, street sweeping, sewer cleaning, flushing, these are sort of those city uses, right? Water departments, public works departments, sewer divisions. We have a certain amount of water that we use just to keep our system going. So something to keep in mind. Some of you might have been involved in flushing before. That was a really interesting thing for our crews during the drought, in particular, because our customers were so interested in conserving water that they really just couldn't wrap their heads around, well, why, are you, the water department, out there just opening up these fire hydrants and wasting all this water? And in reality, we weren't wasting water. Yes, it is true. We were using water. It was going down, the storm drain after we dechlorinated it. And why? Because of water quality, right? If you have dead ends, if you have areas of your system that, sometimes have a low chlorine residual, then you are going to have to flush. For those of you who might not know, water, right, has to maintain a certain amount of chlorine when it's in a public water system called a chlorine residual. We typically chlorinate at a treatment plant or at a well sometimes. And from there, it goes out into the distribution system. So the chlorine will dissipate or be used, is probably a better way to put it, with age, with time. So water age is how we think about it. And that greater the water age, typically the lower the chlorine residual. So if you have this one little water main with maybe only one or two services coming off of it, basically the water isn't getting turned over enough. There's not enough water being used to get fresh water, so to speak, in that main. So we have to periodically come through and flush the main, which is to say we open up an outlet, be it a blow off or a fire hydrant, what have you, and we flush that water main just to get some movement through the pipes, to essentially get new water into the pipes so that the chlorine residual remains high. So that's what we mean when we say flushing. Sewer cleaning, I am not the sewer expert. I do not work in that division. However, we have Vactor trucks and what have you where, we suck up water and we use it to flush the sewers to basically to clear debris, right? If you've ever seen fats, oils, and greases, right? Fog, you'll hear of fog programs in the industry. Fats, oils, and greases can really clog up sewers. So we will use water to flush them. For us, fortunately, we're able to use recycled water some of the time. Not all the time, but some of the time we can use recycled water, and that will cut down on our potable water usage. Very, very good thing for us to be doing. Hopefully more sewer divisions are able to do that in the future. And water loss, something that people kind of forget about, but your distribution system itself will leak from time to time, and sometimes constantly in places, right? When you have miles and miles and miles of pipe and it's under asphalt or cement, there are small leakages that you're just not going to see until they become big leaks. So there is this idea of system loss, right? Not every drop of water that we put into the distribution system comes out of it, right? And we measure this the most basic way to measure it is simply by saying, okay, how much water did we buy from Metropolitan and put into our pipes? How much water did we pump out of the ground and process through our treatment plant and put into pipes? Okay, take that number, add those two numbers together. That's what went in. And then take all of our water sales that went through all of our customer meters and find the difference, right? So water in versus water out. And that number that you're left with is water loss. Water that went into your system, but it never went through a customer meter. It got lost, essentially, somewhere in the system. So, like I just mentioned, flushing, right? That could be, in a sense, water loss. Now, we do account for that because we are actually putting that water to beneficial use, right? We're using it to maintain water quality. So I wouldn't consider that water loss. But main breaks, right? Main breaks happen. Shared fire hydrants. I cannot tell you how many fire hydrants gets hit in our city in a year. I did a little research on it once, and it was an astonishing number. People just like to hit those things. Maybe we should paint them a less bright color. I'm not sure. Um, but things like that, just general leaks. It happens. And the older the system is, the more water loss there's going to be. We like to keep our water loss, under 5%, ideally. Under 2% is, I think, where we're hovering these days. But some cities, older cities, Boston, Montreal, cities like that are quite old, and also, have colder temperatures, which can affect pipes, making them brittle and sometimes burst. They tend to have more water loss, right? It just makes sense. Older pipes, they're going to leak more. Okay, so the careful management of your distribution system and constant sort of water analysis can help you to cut down on water loss, to cut down on your consumption, and to increase, in a sense, your water conservation. It's just as simple as that. If you're serious about water conservation, then you need to have good utility management, right? It's just kind of like making sure our house is clean before we ask our customers to clean house. That's really what it boils down to. Oh man, again? Okay. Now, I'm going to leave you for a little bit. There's going to be some more info about meters. There's going to be more info about volume. We're going to have a couple videos with somebody else in there talking about meters. That way you can actually see some images of meters in person. Well, as close to in person as we're going to get. And there you have it. All right. Thank you.